The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The broadcast is now starting. All attendees are in listen-only mode.
Let's give it about 30 seconds. There's a lot of people that are signing on right now. Think I should go ahead and get started, Heather, or just keep, there's still a lot of people are clicking in.
Everybody a few minutes to get logged in. That number going up as we sit here. Everybody.
You're Heather, you're cutting out on us. I think we should go ahead and get started. What do you think, Heather? We ready? Good morning. Let's go ahead and get started. There's still people clicking into the webinar. It looks like we've got about 380 people on so far, and probably double that in the next 20 minutes, be my guess. Welcome to the first day of the Compost Use Best Management Practices webinar. My name is Jack Broadbent. I will be one of your hosts. I am a supervising landscape architect at Caltrans in the Division of Design. I graduated from Cal Poly State University, San Luis Obispo in landscape architecture. Your main host is Heather Williams. She is a senior in the Organics Material Management Unit at CalRecycle and graduated from Sacramento State University in Environmental Studies. I want to thank all of you for joining us this morning. Special thanks to our presenters who will share some of their expertise and knowledge with us this morning and over the next 2 days. And a special thank you to our team members of CalRecycle and Caltrans. There are a lot of people behind the scenes ensuring as we embark on this webinar, we provide you with a great learning experience CalRecycle and Caltrans have been partners, as far as I know, over 20 years, probably more, focusing on products made from recycled materials, such as concrete, glass, plastic, tires, and organic material. This partnership, in conjunction with industry, has led to fantastic innovations, new products, new markets, and new uses for recycled materials, such as recycled concrete for road base, rubberized asphalt concrete, rubber vegetation control mats, plastic lumber, crushed recycled glass mulch, and what we're here focused on today, recycled organic material as a form of compost. We have an incredible lineup of presenters for you today. You are all in for a great treat. We have experts from a wide variety of backgrounds, and you will learn so much about compost, how it's produced, and its benefits. Now, here's Heather. She's going to cover how you can submit questions to interact with the presenters. Heather? You're muted. Heather, we can't hear you.
Hopefully you guys can't hear all the beeping that I'm hearing in the background.
No, it's people probably clicking in, but we can hear you now. Thank you.
Perfect. So today, after each of this meeting's panel of presentations, we will have a question and answer session. And now I will briefly cover some of the Q&A instructions. So you know what to expect. If you're using the platform and would like to ask a question, type your question into the question. It will not be a hand function today. If you are watching the webinar via the Cal EPA broadcast, the organics inbox email address that you see on your screen, or recycle.ca.gov. For either platform, you may send in questions at any point as soon as they come to you, as they will be answered in the order they were received as much as possible. Also, please keep in mind the world of compost is a large topic. Today we will focus on questions or clarifying material presentation, such as compost use and specifications. Any questions we are unable to get to during the webinar, we will respond to them by email after the event. And now Jack will get us started as he is moderating our first panel.
Excellent. Thank you, Heather. Today we have 3 sessions. Each session will be managed by a moderator. Moderators will introduce our speakers throughout this 2-day webinar. I'm your moderator for the first panel, Benefits of Compost Use. This morning we have Dr. David Crone and Dr. Vick Claussen. Your first presenter is Dr. David Crone. He earned his doctorate in 1992 from Cornell University in the Department of Biological and Agricultural Engineering. For the next 29 years, he was a cooperative extension specialist in the Department of Environmental Sciences at the University of California, Riverside, where his research emphasized the beneficial use of municipal and agricultural residues as soil amendments and fertilizers. Dr. Crone retired from the university in July 2021. Congratulations. He is past chair and current vice chair of the Board of Riverside Public Utilities. Dr. Crone, it's all yours. Thank you. You're muted.
It says you are unmuted. Did it happen? We were hearing you were fine this morning.
Say something, see if we can hear you, Dave. Interesting.
Jack, should we have Vic do his presentation?
Yeah, I think so. Dave, is that going to be all right if we jump to Vic and then put you on next? And Vic, are you ready?
Ready.
All right, great. Let me introduce you real quick. Apologize about the technical difficulties this morning, you guys. We've got people all over the nation doing these presentations. Your second presenter is Dr. Vick Claussen, and then we'll go back to Dr. Crone once he gets his microphone up and running. Dr. Vick Claussen completed graduate work in soil science at the University of California, Davis in 1992. And then he held a research position in the Department of Land, Air, and Water Resources. He specializes in rapid site evaluation of drastically disturbed sites where all the topsoil and biological activity are removed, and development of constructible treatments to regenerate required soil functions. The critical function that typically needs to be corrected are infiltration to reduce the runoff and adequate rooting to store the winter's moisture for summer growth. Soil organics are often a missing component of drastically disturbed sites, and composts are a common amendment material. Dr. Vick Claussen has worked on projects with federal, state, local governments, and services for private landowners. And just a personal note, Dr. Vick Claussen and I have probably worked together for 25 years now, so appreciate it. Vic, it's all yours.
Okay, thanks for the introduction. I'm going to
We just lost you, Vic.
Vic, I believe you are muted now by yourself, self-muted.
It doesn't, oh, there it goes. Okay.
Don't touch anything. Perfect.
Seriously.
Yeah. Go ahead, Vic.
Anytime I hit advance, it mutes me again.
Oh, interesting.
Okay, so I'll start in here, but at this point, I don't see my advance function.
Yeah, let's have Heather advance your slides then.
Okay, so the first thing just to look at quickly, this is the use in these drastically or agricultural soils. So this really follows David Crone's production information. So it's a little out of order, but you can go back to use and management when you see his presentation in a bit. And in this case, we're looking at what these composts do in the soil after they've already. Heather, second slide. So soils without sufficient organic matter are kind of shown in the upper left. These become dense and packed, and they infiltrate poorly. And because they're weak, when the water runs over them, they just liquefy and slump down the slope, as you can see in this canal bank image. In contrast, gardening type soils are built up through repeated compost amendment into thick organic rich layers with high infiltration, high moisture retention, and high fertility. So these features of these garden soils are provided as the compost decomposes. It's the decomposition that makes these soils so rich. And of course, when it all decomposes, we've got to add more onto it. Next slide. So now if microbial decomposition uses up most of these organics, these added organics in a few years, how do natural soils actually get richer and stabilize and retain organic matters? In field and wildlands or non-agricultural soils, these long-lasting water-stable aggregates shown here on this shovel are formed when organic films like the compost teas you know about coat on the mineral surfaces or bind to layers of clay. This protects them from microbial decomposition and they accumulate as soil humus. Microbes still decompose most of the added organic matter, over 90% in a few years, but a small amount becomes stabilized and over centuries builds soils as we know them. Next slide. After they're formed, however, these water-stable aggregates that form are very strong and they can keep their structure even when yanked out of the ground in this picture or when rains or flooding liquefies them. So soil function, it turns out, is a balance and a trade-off between sequestering carbon and building soils versus decomposing them to provide the fertility that we want. Next slide. This image shows a new pile of leaves and wood chips that's starting to heat up, which is visually shown by the steam plume coming off, showing microbial energy release. In these types of fresh materials, finer leaf tissues will decompose faster, while the coarsey woody materials break down more slowly. So the release rate of fertility from these completed composts can be modified to somewhat by the producer during compost production. Next slide. So as compost matures and cures, it's a mixture of coarse woody materials and the fine duffy material that you see by this knife. In an unscreened compost, as it comes out of the pile, a lot of coarse woody material remains. And when you put it out on the ground with the additional shredding of application and transport, microbes use up a lot of the available fertility as they start to decompose the remaining pieces. On the other hand, if you take the material you see in this shot next to the knife and screen it to get rid of all the woody materials, you have a very fine cured material that will release nitrogen right away as it's in the field. Next slide. These nitrogen release rates we measured in a granite sandy soil to compare them to what a normal topsoil would release right. How could we match compost release to natural topsoil release? In this slide, we have some mature aged compost that would be called cured now. And then in the lower, we have some high fiber, which would be unscreened, very woody compost. And these are compared to a topsoil from around the Tahoe area that had pretty high organic matter, but was not disturbed. And what you can see is that some of the yard waste compost called mature aged compost, they'll release nitrogen right away in that initial spike around, a week or two. And then they kind of equilibrate and start to pump out a steady release of nitrogen. Whereas the very woody materials actually decompose or retain nitrogen for a little bit. And then as they cure, they start the nitrogen release rate. And this can be useful for a couple of strategies. If you have a very large volume you're putting out in the field, if it's the coarser it is, the slower the release rate and the less nitrogen gets leached away or available for weed growth.
Got about 5 minutes.
In the next slide, we see that if you just use the fine materials, it starts to release. And in fact, the release rate of the fine materials is not different than the topsoil. So it really does mimic a natural soil material. The take-home message that compost amendments have a service life of a few years, and much of the carbon is only a few percent remains, but you can build it up if you don't till these soils after they stabilize. Next slide. So the non-nutrient effects of compost and organics are also important. In this case, this is a peat material, but it's a coarse fibrous material that holds a lot of water at the wet end. One of the later speakers method for measuring the amount of water in these wet composts. Next. However, when the soils start to dry out, and I use this out of an irrigation furrow, in the background on the upper right, the soils are dry and dusty. When they're this dry, the compost doesn't hold much water. It's only where the wet soils are in the wetted furrow, a lot of moisture. So you got to be careful in non-irrigated plants have too much fluffy organic matter. Next. Well, what these coarse organic matters do is keep the soil open. Water and compost tea and organic matter, organic films will wick down through the profile, and soils actually build themselves from the top going down through these layers. And in this case, this is a soil that's very much not developed, about a foot down, but the top is relatively well developed. Next. Another non-nutrient effect is to reduce evaporation and save the moisture that you do have. And here I'm just showing coarse shredded woody material. These materials keep soils moist by keeping them cool. They don't really form an airtight layer. Just keep the soil cooler, and the cooler it is, the less it evaporates. Next. And another thing they do is especially wood shreds as opposed to wood chips, out the load of surface traffic or vehicles so that it doesn't pack down the surface soil. And here you have a picture of an environmentally destructive soil tromping around out in the field and packing down the soil except where there's a good mulch layer. So the key summary points for this kind of soil use and management are that no doubt compost of plant available nutrients, but they also decompose after a while, and that's what gives them the benefit. Compost nutrient release can be modified somewhat by selecting the particle size of the applied material. Compost can regenerate soil structure, but it takes a while and you can't till it. That tends to undo all those stored carbon layers. And then lastly, compost can really when they're very wet, but they don't do as well when they're dry. For that, you need so those are my main take-home points. And to you, Jack.
Thank you very much, Dr. Vick Claussen. Excellent. And Dr. Crone, hopefully your microphone's up and running if you want to go ahead and start.
Oh, can you hear me?
We can hear you. Yeah.
Excellent. Thank you. Sorry about that. Okay. I'm going to talk about compost in California. And let's see.
You may just want to say next slide and have Heather.
Yeah, next slide if you're doing it. Next slide. Okay. So this is what composting looks like on a commercial basis in California. We call it thermophilic composting. Thermophilic means hot, and the fact that it gets much hotter in these will in your back, and that's very important for reasons that we'll see. Next slide. Composters are managing the compost process to make it happen efficiently. To do that, they create an optimal environment for compost microbes, fungi and bacteria that do the work. In the pile, these microbes take the carbon in the pile and they take oxygen from the atmosphere and they use it to produce carbon dioxide, water, compost, and heat. We eat our breakfast, we breathe oxygen in the air to take the breakfast and break it down into carbon dioxide and water and heat, and that's the energy. We call this process respiration. When we do it, it's respiration in the pile. Next slide. Why do we compost? Two sets of reasons that we'll talk about. One, to eliminate disease organisms, animal, plant. And second, we want to produce a stable and safe soil amendment that's going to release nutrients rather than, it's not going to have offensive odors, and it's not going to be phytotoxic. So if you don't do this properly, you can actually create a material that can be poisonous to plants. If you do it properly, it's the healthiest thing you can do for plants. So next slide. There are two stages post process. First is composting. That's when it's really hot. That composter is managing to make sure that it's really optimal. And during the active phase, there's so much activity in the pile that temperatures start to go up. Just like in a gymnasium when it gets all hot and sweaty because everybody's same thing in a pile. And the temperatures can really go up dramatically. What's it like inside the pile for the microbes? A Roman orgy for microbes, okay? So huge party, and they're grabbing food and they're eating it and they're not even finishing it, and they're throwing it over their shoulder, and they're grabbing another thing of grapes and a coconut or whatever they're finding, eating a bit, throwing it away, grabbing some more, and multiplying and multiplying. That's the act. It's a huge party. What's left over after a party, though? A mess. So during the active phase, material is broken down very quickly, but there's a lot of compounds left over that smell bad. They're odoriferous, or they're actually toxic to plants. They need to be further decomposed. So what the composter does is allows the pile to sit, and that's called curing. The active phase is anywhere from 3 to weeks. Curing takes a few weeks to even, it can take a few months. At the end of the curing phase, when the pile is just left alone, the microbes are hungry, they eat all that leftover food. Nice, stable product that people can use. Next slide. The heat is important for so many reasons. One is composters are in the business of moving, not keeping compost on their site. So when the pile gets hot, the efficiency of the microbes goes way up. 18 degrees centigrade, microbial efficiency roughly doubles. So if you have a pile that's at 72 degrees sort of ambient temperature, and you raise it to 150 degrees Fahrenheit through action, how much faster will organic matter decompose? Next slide. 25 times faster. So you're processing this material much faster, and that heat gives you of accelerating the process, but next slide. So we have this turned windrow. Next slide. They're very big, they're very tall, and we turn them typically. Systems too. California systems are still turned wind. Sometimes we blow pile, but the turn windrows are predominant because they're most affordable. How do they work? Why do you turn the pile? People think turn, and the truth is there's so much going on in these parties that air is used up very quickly, minutes. But what you're doing when you turn the pile is you're fluffing it up, because this is a remarkable engine, this compost pile. It gets hot in the middle. So the gases in the pile expand because they're hot, and then it's up out of the pile. That thing is full, but it's deficient in oxygen. But nature leaves, oxygen is drawn into the pile as in fresh air, and that replenishes the pile. So what you're doing when you turn the windrow is fluffing it up, opening the air passages so that air can get in. And in time, those air passages collapse. So you need to keep doing that every few days. Next slide. All right, we talked about heat. Composting, I need to add a new thing here. Composting is a biosecurity for animals and humans. Think about it. You're taking material from one site, vegetable material, to a new site to use it. Plant pathogens. Pathogens cost millions and millions of dollars to farmers. They're a big concern. Composting takes care of most of them. We also have concerns about animal and human pathogens. We're often growing food, for example, and if there are human pathogens or animal pathogens in vegetable material, we want to inactivate them. And composting is fantastic at inactivating pathogens. Next slide. Germs. So we're protecting the public through composting. Next slide. And we're in the health. And when I say plant pathogens, viruses, they have bacterial infections. We're talking about weeds. Composting doesn't eliminate all weeds, but it gets most of them. Next slide. Soil improvement. Okay, you just learned a little bit about this, so maybe I'm going to be summarizing what you just saw. Next slide. So why would we use soil amendments? We're mixing compost into the soil. One is to improve tilth, which is how workable the soil is. Can you plow it well? We improve the amount of water that can be held in the soil. We improve aeration. It turns out roots need air too. They're part of the plant. They're growing. They need air. If you open it, compost use opens the soil so you can do it. It also improves infiltration capacity, which means you can get water down into the soil, which is often a problem. It can adjust the pH, makes the pH more neutral. And it also promotes microbial activity and diversity. So you build this wonderful, healthy community that can defeat invading plant pathogens. Next slide. All right, so this is a soil food chain. There you go. So you've got plants here on the left growing. They've got roots. You add to that, and then these fungi, bacteria will feed on that organic matter, and they provide food for all of the higher organisms. Now they're eating organic matter. It's normally by plants and plant roots. Their food. So it's in their interest to improve plant growth because that's their food too. When you add organic matter, you're giving them that they can use, and then they transform the soil. It's the microbial activity that transforms the soil so that plants grow better. It's that, so you're providing the compost. The compost isn't changing the soil. It's the microbes breaking down the compost that changes the soil by forming those famous aggregates you just heard about. Next slide. How does it work? Well, the fungi send out little roots called hyphae that tie soil particles together, and bacteria secrete polysaccharides that act as glue, like paste that you weren't supposed to eat in kindergarten. They paste the particles together and they form aggregates. Next slide. So this is a picture of aggregates. The aggregates improve the structure of the soil, and that gives it the properties of holding water, allowing air to penetrate, allowing water to penetrate, facilitating drainage, and allowing roots to penetrate. And that will persist even when the compost is gone, as long as you don't drive a tractor over it in the rain or something. It's a physical change to the soil. Next slide. In California, they don't talk about this in a lot of the country. In California, we have salt concerns, and people have questions because compost do contain salt. Most of the salt, the overwhelming majority of salt in farm systems doesn't come from compost. It comes from the water that you're applying. And when you're not using compost, you have to worry about salts because the irrigation water brings in salts, the water evaporates and leaves the salts behind. How do you get rid of it? Well, you add a little bit of extra irrigation water and it rinses it out of the root zone. Composting helps this process, even though you're adding some salts, because it opens up the soil and facilitates drainage. So you can rinse the salts that you're adding with your irrigation water and any that are in the compost out of the system. Another thing to keep in mind is EC is how we measure salts. It's just jargon. And if you have a high EC compost, it's usually because it contains nutrients, and nutrients are mostly salts. And if you have a really salty soil, you can actually use compost to remediate it. So it's not a problem, it's actually a solution. Next slide. New thing, California now has physical contamination limits. As we're trying to divert more and more waste, there's a tendency, there's a concern that we're going to be not doing, we composted the easy stuff and now the stuff might be dirtier. CalRecycle has a new rule. It limits contaminants to 0.5% dry weight or 0.1% for film plastic. And that picture there is what 0.1% film plastic looks like. Okay, so that meets the standard. It's not a very, at 0.5% dry weight total isn't really that much material, but 0.1% film plastic, you can see it and it can be a concern. So I think a challenge for everybody is to get that film plastic level down. 0.1% really is actually a lot. Next slide. One thing we think about when we apply compost is nutrients. It contains nitrogen in both organic forms, which are slow release, as well as some that's available immediately. It contains phosphorus and it contains potassium. People pay for these. They're actually very, very expensive. They also use a lot of energy. So if we can reduce those, it's a good thing. And you can with compost. Next slide. It also contains micronutrients, which are sort of like vitamins. You may not need them, but it's good to have them there, just in case you do. Next slide. Now, what about the fertilizer value of compost? It's not fertilizer. It doesn't come out in the same way as fertilizer. It's slow release. It's not available immediately. But you can, as you add more compost to the soil, you have a bigger buildup, a bigger bank of fertilizer in the soil, of nutrients in the soil. So you can gradually, over time, reduce the amount of fertilizer that you need. And materials with what are called low carbon to nitrogen ratios contain more nitrogen, and they are usually better fertilizers. So those would be one that would have, like, say, manure in them. Next slide. So in summary, composting breaks down organics and stabilizes them. And in that process, it eliminates plant and human diseases, and it reduces weeds. Composts work with microbes, inspire microbes to improve the soil structure. And with this improvement, soils can hold more water, and they also transmit water, so you can get salts out. Nutrients are retained. They actually compost to help to hold nutrients in the soil, and plants do much better. Compost salts are just like any other salts, except for they're more nutritious. And composting actually helps you to reduce salts. So that is my talk. Thank you very much.
Thank you, Dr. Crone. We'll go to questions now, and you can send questions in through the question pane on your webinar, or also send it in through organics@CalRecycle. And you can send those questions in anytime during any of these presentations. We'll collect them and then forward them through our moderators to the panelists. First question, the webinar is being recorded. We plan to make Heather, this one's more for you, the first question. The webinar is being recorded, and we plan on making it available on the CalRecycle website. So Heather, I'm assuming we'll send out a web link to them eventually?
Yes, it may take us a little while to get everything worked into an accessible format, but we do intend to make that recording available.
Cool. All right. And then
someone had a question if there is going to be different information on tomorrow's presentations or the same information, and it is going to be different. We have a whole different set of panels for you in store tomorrow.
Very different. just so you guys know kind of the structure of this whole webinar, we started with Dr. David Crone and Vic to kind of give you an idea of how compost is made and some of the beneficial uses. As we move through the webinar, you're going to get into more and more practical applications. We just want to set the foundation for you so you understand the value of compost, and we set aside some concerns that people may have about compost that seem to repeat themselves. Heather, am I supposed to ask the questions, or do you have people that are doing this?
I believe Esmeralda and Ray are going to help us out with that. Are you ladies available right now?
So as was already mentioned, you can use the question pane, you can use the chat, you can also email the organics inbox. The first question that we see is coming from Emily Stein, and it is, can composting eradicate mushrooms, fungi, and their hardy spores?
So Vic or Dave, either one of you can.
Dave, that's you.
Sure, the composting process, eliminate is always a strong word, okay? It reduces them dramatically. There may be some spores that survive the heat, but yes, it reduces them very dramatically. Most plant, there are some organisms like tobacco mosaic virus resists heat. It actually tolerates heat, but that's very unusual. And that's not a fungus.
Thank you. The next question is kind of on that same note. It's from Michael Ferrara, asking, if compost is great for plants, how is it good for weed control?
Well, it's good for weed control. First of all, it eliminates most weeds from the material. So you could take stuff and just chip it up and put it out there. But when you compost it, most of the seeds are inactivated. There are some resistant species, but palms, for example, but most of them are inactivated. Secondly, you get weed control mainly through mulching. And when I didn't talk about mulching, Vic did, but when you cover the soil, what happens is when weed seeds are germinating, they have to reach the sun before they can get energy, and the weeds block them from getting to the sun. So most of them won't be able to make it out from the seed stage to the plant stage. They just run out of energy. I do want to say one thing about mulch, that another reason to use compost as mulch, and not just to chip it up and put it out there, but to use compost, what are called overs, the coarse materials, is fire. We're having a lot of fire problems with mulches out in my area, and it's materials that aren't composted. When you compost material, the oils and resins that are so flammable get broken down. They have a lot of energy, and the microbes use that energy. If you just chip it up and put it out there, if you have any appreciable depth at all, you can get fires that are really, really hard to put out. So that's just another reason to compost.
Okay, the next question is coming from Diane Hazard for Dr. Crone. She would like you to speak to salt level variability with manure-based compost.
Well, composts that contain nutrients have salts. And what you can do is there are certificates that reliable composters will have, STA certificates that I think you'll hear about later, that will characterize the salt content of the material. And you'll see that really nutrient-rich composts tend to have higher ECs. And it's a trade-off. You have to be able to tolerate that in order to get the advantage of the nutrients. Now, if you were to measure the salt content of say a nitrogen NPK fertilizer, it would be off the charts because you're basically adding salt. Okay, so yeah, it's variable. You can get less salty materials and you won't have the same nutrient benefits, but you'll have all the other benefits. So for example, Greenway's compost would have lower ECs. Some biosolids compost can have ECs as high as, say, 15, quite high. And you just need to keep that in mind. But as long as you're managing your water well, if you're managing the salts in your water, they're going to be okay for the salts in the compost. Yeah.
Another question. How hot can compost get during the composting process?
I don't want to take all the questions here. It gets up to, 130 is pretty normal. If it gets up about 160, that's kind of at the high end. 170 is very high. If it gets up much above that, actually what can happen is all those beneficial microbes in the compost pile can be killed because of the heat, and that does happen. So you can sterilize a compost pile by letting it get too hot. And that's actually a big problem, because when that happens, that healthy community is gone, and then pathogens can move in to the pile. So you don't want it to get overheated, because it stops the process, and you can end up growing something like salmonella, which you don't want. So it can get too hot.
Thank you.
Yes, thank you both.
Go ahead.
Sorry, was there anything you wanted to add before the next question?
No, I was going to go to the next question.
Okay. The next question that we have in the chat is from Renee Caprillion. What is the long-term impact of film plastic in compost breaking down into the soil?
We don't know. We haven't studied that yet, and it's a concern of mine, because we simply don't know. If it's in the soil, it's fairly stable, but what you see is sometimes it'll blow across the surface of the soil as the soil is agitated by plows or earthworms or whatever, and then it can possibly reach surface water. So it's something we all need to think about, and it's a real reason to keep our plastics low. The ones that are regulated are above, I think, 4 millimeters, and so we don't even have regulations for microplastics, which would be smaller. So yeah, so it's a question. It's something we all need to keep an eye on.
I'm going to go to the next question. If compost has a mix of larger particles, is that helpful for long-term release of nutrients and better for water infiltration? And Vic, I think that question's for you.
Yeah, I tried to cover some of that briefly, but the process of including some of the compost overs or woody fragments definitely stalls off the positive N release rate. You can say it immobilizes N, which for production agriculture is bad, but for natural plantings, wildlands plantings, we routinely use that to slow down the N release so that it's more synchronized with native plant uptake in subsequent seasons even. So definitely we use that. The problem, like David just mentioned, is that some of the unscreened composts have a lot of plastic left in them. So it might be you have to get a screen compost, 3/8 or whatever is commercially available, and then add back in the compost overs that have already been cleaned up. So there's a number of ways to do it, but definitely it's a strategy I use to slow down N release so that I can add more total amount of compost onto my sites.
Let me throw a follow-up question with you, Vic. So if you're working on a drastically disturbed site like a cut slope, do you do a 50-50 blend of fine compost and the wood chips or the overs, or what kind of blend?
It depends. It depends a lot on how deep that soil is. If I know it's a cut slope, but if there's rooting that goes in, even a 50-50 blend of a pretty high thickness can incorporate within the soil and get plants to grow and root that in and kind of lock that up. If it's a real slick cut slope, then you have to be careful, and a 50-50 blend actually is a little on the hot side for too much fine compost, because basically because it gets dry and the microbial incorporation quits when it's too dry. So I'd say kind of conditional, but 50-50 is where we start, but we're dealing with soils, not hard cut slopes.
Excellent, thank you. And then we've got another question from the audience, Jan Mays. Can you please elaborate on fungally dominant composting? What are the advantages versus issues? If your mainstream is wood chips, what is the best source of high N stream? Hopefully that makes sense the way I read it.
Vic, do you have anything on that?
I'm not on the production side, which it might be composting. She talks about like it's, or they talk about it being active composting, but we do see a lot of fungal growth from the soil up through a compost layer into the overlying wood chip mulch or composted overs mulch. And there's studies in agriculture where less tillage means more fungal growth. So that part is on the use and management side. Fungi are able to bridge from the moist soil up to the drier compost. We like that a lot, but it's different than having a composting process that's bacterially versus fungally dominated. And I'd pass that off to David.
All right, I'm not familiar with the term fungally dominant composting, and I don't use air quotes very often. So, but I'm going to fake it because most of the activity in a compost pile is bacterial. They're small. They're much more efficient than fungi. Fungi get their superpower because they can break down something called lignin, which is, as you refer to wood chips, it's the compound in wood that protects the wood from bacteria so that your trees don't fall down. And cellulose is the #1 substance in vegetation. Lignin is the #2. It protects the cellulose, and only fungi break it down, which is why when you go in the woods and you see a stump, you'll see fungi growing on it. When you say fungally dominant composting, I mean, you see that in mushroom compost operations. But they grow much more slowly than bacteria. So I would think the main problem with it for conventional compost, if you're really trying to enhance fungal growth or rely on fungal growth, is it would just be way too slow, and it wouldn't be thermophilic. You wouldn't get the heat. And if your mainstream is wood chips, fungi will be present. They'll be doing some of the work. You can supplement it with nitrogen, and it doesn't really matter. I mean, you can use fresh grass, you can use manures, you can use biosolids. I would just say, use what's available. And the principles are the same, but like anything, your local results, your local approaches will need to be fine-tuned. So start small with batches, see what works, and then expand.
Excellent, thank you. And you guys seeing any other questions in the question box or on the email system?
Yes, so Lauren Team Brazil would like to know, how is commercial composting used throughout California? I think specifically they're asking about the compost created at transfer stations.
How is it used? Well, it depends on where you are in California. Northern California has vast areas of farmlands in the Central Valley, and most of it is used in agriculture. And in Southern California, we still have farmlands, but there's less. And so trying to develop markets in communities and landscapes, but we're kind of early on that. I think we could do a lot of work there, taking mow and blow guys and introducing a whole new product for them to market to their customers, which would be composts and mulches, showing them how to do it properly so that they can save water for their customers. Right now, it is legal to apply rather phenomenal amounts of compost to ag land. And so in Southern California, you see a lot just kind of spread very thickly and without, more than is actually needed. So you want to get, but that's kind of a disposal mode. It's like healthy disposal. We really want to get to beneficial use. So what I'd like to see is us doing a better job in Southern California of generating our compost locally and then using it locally.
Excellent. And I think we have time for one more question, if there's another question in
Oh, and CalRecycle is a big customer.
Yeah.
I mean, Caltrans, sorry, Caltrans. Yeah, is a big customer.
So for the last question, I'm going to jump to Jenna Rorypaw. Can you compare the benefits of thermophilic composting to composted digestate?
Well, composted digestate, it depends on which kind you're talking about, but say you're talking about green waste that's gone through the digestion process, or even manure. Digestate is what's left over usually after methane production, right? So you've used some of the available energy to generate methane, and then you have this digestate left over. That isn't really suitable for use by plants yet, so you still need to compost it. So once the digestate is composted, it's really like any other compost. There's not really a difference. But you can't just use digestate without that, solids from digestate without that extra step. The liquids you can spray out and use. Excellent.
I want to thank both Dr. David Krohn and Dr. Vick Claussen for your expertise this morning on our panel. We've got 3 minutes for a break, folks. So if you want, you can just give 3 minutes. We're going to start right up at 10 o'clock. And here's a fun question, food for thought during our 3-minute break. Thank you.
Bye, everybody.
Thank you, Dr. Krohn. Bye. Thank you, Vic.
Welcome back, everybody. Good morning, I'm Ken Murray and I'll be your moderator for panel 2, compost used for roadsides and compost specifications. I'm a senior landscape architect at Caltrans in the Division of Design. I graduated from UC Davis with a degree in landscape architecture. And now for our 3 presenters, who will be Zach Tanner, Mike Ferrara, and Hillary Nichols. Zach Tanner is a landscape architect at the California Department of Transportation and has over 15 years working in both the private and public sectors. Throughout his career, Zach has helped advocate for climate-adapted design solutions and sustainable landscape design initiatives. His areas of interest and expertise are ecologically driven planting designs, promoting sound horticultural practices, and developing water-efficient landscapes. Mike Ferrara graduated from Utah State University in 1989 with a bachelor's in business administration and a master's in landscape architecture. After college, he worked 6 years in various private sector landscape architecture firms. He started his career with Caltrans in San Diego in 1992. In 2000, he was promoted to branch chief in the headquarters contract office in Sacramento. In 2014, he transferred to headquarters landscape architecture program as a standard senior. He has extensive experience with the development, advertising, bidding, and awarding of Caltrans construction contracts, as well as expertise in specification development. Hillary Nichols holds a BS in horticultural science from NC State University and has 20 years of experience in the horticultural industry. Hillary is the market development coordinator for the U.S. Composting Council, where she manages the Seal of Testing Assurance Certified Compost Labeling Program and the Compost Analysis Proficiency Lab Program. Hillary works with the U.S. Compost Council committees to market compost use, design a national compost product search engine, and improve compost parameter test methods and lab proficiency testing. Prior to the USCC, she served as a senior horticulturist at the Atlanta Botanical Garden. She has written for Fine Gardening Magazine and a leader in both the National and Georgia Perennial Plant Association. So Zach, are you ready to start your presentation?
I am.
Okay, let's begin. Thank you.
All right. Good morning, everyone. Thank you for the introduction. And today, I want to talk to you about how we at Caltrans have been using compost-based best management practices on our highway roadsides. It looks like I can't advance my slide. Let's see.
There you go.
Okay. So a little bit first about Caltrans. We're the California Department of Transportation. We have 12 district offices and a headquarters in Sacramento. We're about 25,000 employees, of which 9,000 are engineers and 300 are landscape architects. And we operate with a budget of about $8 billion per year and complete about 650 projects per year. So we're a large organization. We cover a large geographical area. And over the years, we've increasingly been using compost on a lot of our projects. And that's really what I want to talk to you about today. So to begin with, I want to start by noting some of the general environmental benefits of compost. One, we know compost builds healthy soils. We know it supports vegetative growth. And 3, when it's used correctly, we know that it can protect water quality. So these are 3 great benefits of compost that tie directly to a lot of the work we do at Caltrans. Compost also has some characteristics of it that make it very useful within our erosion control applications. For one, the compost helps establish early vegetative growth. 2, it protects the soil surface from splash erosion. 3, it has a high water holding capacity that helps slow down and disperse the energy of the sheet flow. And then 4, it has some natural biofiltration characteristics. So some really good characteristics of compost that make it very useful in a lot of the erosion control work that we do. And so now I want to talk to you just a little bit about some of the projects we've completed within the last couple of years where compost was used within those erosion control applications and also used in various ways on other projects as well. So this is a project that's located off Highway 101. It's just north of Salinas, which is between Los Angeles and San Francisco. And it's a large project, 108 acres, and applied about 45,000 cubic yards of compost. And then here you see the existing site condition or the existing native soils. So it's an aromatous sand, which is a cross-bedded sand with clay layers. And as you can see, it's highly erosive. It lacks organic matter, and it has a high runoff capacity, and it's made it very difficult for us to control erosion within this corridor. And so on this project, we had some really large and steep slopes. This is a photo from that project under construction. And because we had having these large steep slopes, we really needed to have an aggressive erosion control strategy. So what we did is we utilized, on this slope, we utilized a compost blanket. And this was done for slope stabilization and vegetation establishment. And what a compost blanket is, it's basically a 2-inch layer of compost that's applied on the soil. And then we come over that with a coir netting and hydroseed over that. And the compost blanket really provided 2 great benefits for us. For one, once we applied that 2-inch layer of compost, that compost acted as a soil cover, and that soil cover protected against any erosion that would happen during a high energy rain event. The compost was able to hold a little bit more water and really buffer the soil from any erosion during the rain event. So that was a benefit we pretty much achieved right off the bat. And then we also had some really good and successful early vegetative growth. So this is that same slope about 6 months later. And you can see a good, healthy vegetative growth here. And these results, these were unlike any other results we've had on our projects going all the way back to the 1950s, actually. I mean, erosion can be, it's problematic in general, but for us, it's particularly problematic. Erosion is a big concern. It compromises the stability of the infrastructure. The eroded sediments get in the waterways and can pollute the waterways. It also gets into our drainage facilities and clogs up the drainage facilities. And so it has a lot of, long-term maintenance requirements to it. And a lot of those, those maintenance requirements have a lot of high short-term and long-term costs associated with it. So for us to get the upper hand on the potential for erosion and to do so within this time frame was very encouraging for us and a great thing to see. So this is a different slope. In this instance, we applied the compost blanket, but then we covered it with blown straw. And this was done on slopes that were 2-to-1 slopes up to 30 feet long. And this as well, this was a very effective way to control erosion. It worked out very well for us. It was also very cost efficient and a really, really good use of being able to apply this compost blanket. And then here's a variation on that theme. So this has the 2-inch layer of compost. It has that compost blanket. And then we cover that with a punch straw. And the punch straw was done to help the straw better bind with the soil. And likewise, it was very, very effective at controlling erosion, and it was also very cost efficient. The only thing with this, the only constraint here is you have to have access from the top of the slope, so you can get the equipment there to help to punch that straw with the soil. And then we also use compost as a form of linear sediment barrier called compost berms. And these compost berms were used in lieu of any fiber rolls. And their intent was to help slow down and disperse the energy of the sheet flow on this slope. So these compost berms were pneumatically applied. You can see the photo on the lower left there, blown into place. And the berm itself, it's about 2 feet wide and 1 foot tall. And then we used a medium particle size compost to help provide some infiltration, but have enough fines in that compost to support vegetative growth. And one of the great things about these compost berms was that once we come back and hydroseed over them, the hydroseed helps knit the compost berms together and hold it in place. But then the berms themselves kind of recede into the landscape and into the slope, so they become less obvious features. So that was a nice added benefit. And then here, these photos show how the compost berms function, how they're good at holding back that sediment of the sheet flow. So they're allowing for some infiltration, but again, holding back that sediment. And one thing to note is these compost berms are intended for where you'll have sheet flows on the slope. They're not necessarily intended for where you will have concentrated flows. So if there are concerns about concentrated flows, you can incorporate these compost berms in conjunction with fiber rolls or even compost socks. So compost socks. This was a different area of the project, and we use these compost socks as a form of linear sediment barrier as well. In this instance, they were used as check dams. And again, these were used in lieu of any fiber rolls. And they were used to help slow down and slow down the water to allow for some infiltration and hold back the sediment. So you can see the photo on the lower right there. It's allowing some water to pass, but it's holding back that sediment. And these compost bombs, compost socks are, they have some constructability benefits to them that are really good as well. So what we found is, the compost socks have a good weight and mass to them. So they have good contact with the ground plane, which make them very effective as check dams. But that weight and mass also means that the contact with the ground plane also means that it don't require any trenching or rope to secure in place. We found that just staking alone was enough to hold them. And then the other added benefit, these socks will be pneumatically filled up with a blower truck. The compost is blown directly into the sock, which means that they can be assembled, right there on site. It doesn't require having to move around heavier, more cumbersome fiber rolls to get them in place. So some nice added benefits of using these compost socks. And then one of the great things about this project was there were areas where compost was used, and then there were areas where compost was not used. And so this allowed us to get some really good performance comparisons. And so here you see a really large slope that basically only had a bonded fiber matrix and some fiber rolls on it. And this is after a really high energy rain event. And you can see the fiber rolls are displaced. The fiber rolls are displaced, and there's some large scouring that happened on the site. Another good example, that's a different slope after the same rain event. The top portion of the slope had compost with some netting. The bottom portion of the slope just had a bonded fiber matrix and some fiber rolls. And I should note that the top portion of the slope did have some vegetative growth on it. And this, I think, really just points to the fact of how important it is to get those permanent erosion control measures in place. And then here's a good comparison. So the area on the left just had a bonded fiber matrix, and the area on the right had a bonded fiber matrix with compost. And this is after that same high energy rain event. You can see the area on the left clearly did not perform as well as the area on the right. And I mentioned it before, I'll touch on it again. Compost blanket is best used and intended for where there'll be sheet flows. It's not necessarily intended for where there'll be concentrated flows. So this sheet was intended to have, this slope was intended to have sheet flows. But due to some impervious material on the road adjacent to the roadside, and then some slight unevenness in the roadside, a volume of water was able to build up and spill over the top of the slope, and this caused some rilling to take place. But this slope is in good condition. I mean, it's got 2-inch soil cover on it, protecting it from any raindrop splash erosion, and ideally supporting some good vegetative growth. And now I want to jump to a different project. This is a project off Highway 101 near Big Sur. And it's an example of a project where compost was used under some really difficult environmental constraints or site constraints. So this was the site of a massive landslide, and the slopes and the roadway had to be totally reconstructed. And you can see it's right on the Pacific Ocean. So it was very windy. And so we had steep slopes with some windy conditions. And our concern was being able to get the compost applied on the full length of the slope and not have it blow off site. So what we did is we blew the compost from the top of the slope and the bottom of the slope, and we blew it on non-windy days. And then immediately after blowing it, we covered it with a hydroseed and tackifier. And then one of the great things that worked out well for us on this project, so this was, all these slopes it was landslide material. So the soil was very coarse and aggregated. And it meant that the compost was able to work itself into the nooks and crannies of that soil type. And here you see, here you see that same slope 6 months later, or I'm sorry, a few months later, after some winter rains. And there's a good, healthy layer of vegetative growth on it. And it was very encouraging to see. We were particularly concerned about getting vegetation established on this site. And then this is a different project. This is a project off Highway 1 near Cayucas. On this project, we were tasked with restoring the site back to its native coastal prairie grassland habitat. And the challenge we were facing here was this pullout area. It was used as an informal parking area. There's some hiking trails nearby, so hikers would use this area, park in this area to access those hiking trails. And then this was imported serpentine material that was imported from a nearby landslide as well. So we had a very compacted soil type on a very difficult soil, compacted soil that was on a very difficult soil type that was hard to get vegetation established on. So what we really needed to do was improve the infiltration here. And so what we did, we applied a 4-inch layer of compost, and we incorporated that 8 to 12 inches deep. And here's that same site 2 years later. So we had some really great success in getting vegetation established here. And then this is a different project. This project's located on Highway 46 East. And this is an example of a project where compost was used for biofiltration. So we had to construct this bioswale. Again, we had some compacted soils. And so what we did is we applied a 4-inch layer of compost and incorporated that 8 inches deep. And we got some really great results out of it. You can see there's some good, healthy vegetative growth, and we were able to improve the infiltration on site. And then lastly, a couple things I want to note when considering compost on your project. The use of compost on your project does allow for some carbon sequestration credits. And really the only thing I really want to note is that there's a number of online websites and online calculators where you can enter in the amount of compost or the volume of compost you want to use, and it will tell you how much carbon sequestration credit you can earn. And then in all of the applications and uses of compost on our projects, we are utilizing a specification that has 3 different particle sizes to it. So our spec notes, we have fine compost, medium compost, and coarse compost. So the fine compost is used for soil amendment and incorporation. The medium compost is used for soil protection and plant establishment. And then the coarse compost is used for compost socks and those compost berm applications. And this was talked about before in the previous presentations. So our spec does address the physical contaminants. It notes that less than 0.5% of physical contaminants by dry weight, and it notes that it shall have less than 0.1% of film plastic by dry weight. But even with those very low percentages, yeah, there's still the possibility that small bits of plastic will show up. And so the use of compost should be looked at on a project by project basis, where you take into account all of the environmental sensitivities of the site. And that concludes my presentation. So thank you for listening.
Thank you so
Zach,
much.
thank you. Zach, thank you for your presentation on the environmental benefits of compost for erosion control. Mike, are you ready to go? I can't hear you, Mike.
Okay now?
Yeah, I can hear you now. Okay, take it away.
Are we okay now? I'm sorry, I have my headphones on.
Yeah, you're good. We can
Okay,
hear you now, loud and clear.
all right, thank you. So in the next 5 minutes, literally, we're going to cover just a little broader picture than Zach gave you on that really nice project, a couple of nice projects there in the central part of California. So we're going to talk here just briefly about Caltrans and how we deal with compost on our contracts, essentially how we bid it out, okay, and how we have our contractors work with it. So if I can get a slide.
Did you click on your presentation? I see the mouse moving.
Oh, click on top here.
There you go.
Okay. Each slide I can move forward to that in that fashion just by clicking. Okay.
Yeah.
All right. So when you look at an organization, our organization, you can see how big we are. We do buy a lot of compost. We use it on a lot of projects, more and more. You're going to see essentially four ways we use compost. There are others too, but these are the four main ways. As you saw in the prior project, we use it as a blanket at times. We use a lot of compost sock. It's becoming more and more preferred method, even over fiber rolls. See a lot of that. You'll see the berms that Zach was showing us, and then also over many years we've been incorporating compost. Oops. The way we do our work is we have to bid things out, and we have something called bid items, and you'll see this is partial list of what we call an engineer's estimate, and you'll see there we have an item for compost sock, and we'll buy by the lineal foot, and we buy compost by the cubic yard. You'll see there. And then we'll have an item that incorporate materials. So you'll see a mix of, most of our items will be a mix of material and labor. Sometimes it's just straight up labor, like you see in the incorporate materials. We also have something called standard details. So this is our standard detail. It's a pretty thick book for our details, all the different things we do at Caltrans, but you'll see a sheet or two in there on what we do on our erosion control. And in this case, this is the sheet that deals with both the fiber roll and the compost sock. And then so we'll have the details and the staking, like Zach talked about, the kind of staking that we give them options to do, essentially, depending on site conditions. In this case, it deals with the staking both on the fiber rolls and with the compost sock. We also, in Zach's presentation, saw a part of the specification on the particle size. I'm going to show you the rest specification here. This is the introductory paragraphs on our specification. Talks about the different places that we can use for a source for the compost that the compost manufacturer can use. It's my understanding that the mixed food waste is becoming even more of a higher percentage of what you're finding in our compost, and hence some of the problems with the film plastic. You also see there in the red box the code of regulations also. When we talk about the quality of the compost that we need, we have both some quality measurements that we'll get to here in just another slide, but also have a code of regulations here under California that also deals with the quality of the compost. In order to know if we're getting the quality that we want per our specification, we have to have something called technical data sheet. That data sheet will also include information related to the U.S. Composting Council, which is the speaker after me, Hillary Nichols. She'll talk a little bit more in detail on what they do, and we use a lot of on what they are producing in order to ensure that we get higher quality compost. And there's the code of regulation, all the different things that it deals with, the metal, pathogens, etc. So this is our main part of the spec with the quality measurements. You know, it's your standard measurements on pH and salts and maturity levels, which are, I think most would know, is critical. Maturity, stability, the physical contaminants we've been discussing there at the bottom, the film plastic amounts that are allowed, and you'll see down at the bottom the footnote note that these test methods are published by the U.S. Compost Council that Hillary represents. There's the technical data sheet, comes from the U.S. Composting Council, that, you know, in order to verify that we're getting what we specified, and that's on each delivery. A compost will come with that, and then that we have somebody called a resident engineer that checks and collects those and ensures that we're getting what we specified. And that's it. I just put this last slide in there to show creativity is still something that I think we all realize that we don't know it all for every project. And here's an example there where we used a snow blower on this particular case to move the compost over onto the adjoining slope there. So that's it for me.
Okay, thank you, Mike. Appreciate that presentation on Caltrans contracts. Hillary, are you ready to go?
I am ready to go. Absolutely.
Okay. Take it away.
Thank you. It looks like I don't, there we go. So I'm Hillary Nichols. I am the Market Development Coordinator for the U.S. Composting Council, which means that I also coordinate the Field Testing Assurance Program, as Michael mentioned. And I wanted to tell a bit of my story. My background is working for botanical gardens and landscaping companies and nurseries. And I started to really believe in compost from that background. When I was at the Atlanta Botanical Garden, we would blow off all the mulch off of our garden beds, perennials, trees, shrubs, and we would apply an inch deep layer of compost because we believe in it, and then put the mulch back on top. And we saw incredible results from doing that. So that's why I'm here, because I believe in it. So I have a question to ask all of you. Is all compost the same? Can you go into the store or call up the supply center and say, I need some compost. I just heard on this Caltrans CalRecycle webinar that compost is awesome and I believe in it. They showed great test results for how it just really worked on all their projects. Are you going to get the same material? So what I want to tell you is that all compost is different. It's a bunch of different types of feedstocks that are decomposed, and it ends up being different no matter where you are. Around the country, it's different from manufacturer to manufacturer. even within one manufacturer, they have different products. So not all compost is the same. And what do you do? How do you figure out how to get what you want? Because as you were seeing, there's a lot of different ways to apply compost. There's berms and blankets and incorporation and surface top dressing. So each one of those has a different type of compost that's best for it. Like Vic was talking about also, you get different types of, different amounts of nutrients depending on what type of compost you have. So how do you compare compost before you buy it so that you can get what you want that has the properties that you want? Fortunately, the U.S. Composting Council took this question and took this problem and created the Seal of Testing Assurance program. Because we believe that knowledge is power. This program is an information disclosure program that if you just look at these test results, you know that you're gonna be able to compare products apples to apples. And part of that is that we test the labs behind the scenes before they test the compost. We're testing the labs to make sure that they're proficient at doing their job of giving you accurate test results. We also require that those labs use our TMECT test methods, which are methods that we created with 60 scientists 20 years ago, and we're constantly updating them with new scientists and new methods throughout the years to make sure that it is appropriate test methods for compost that are being used to test the compost, which makes sense, right? So that's what this STA program is a uniform product label. So this is what that sheet looks like. Michael showed it to you earlier. I want to make sure that you see that there's two sides to the sheet. The first page is really helpful for all of you that have specs that you're trying to make sure that the compost that you purchase meets certain specifications. So in that third column, you'll see there are the test results that the composter in front of you has. And then in the fourth column is the test results that you are expecting. That's what you need for your specifications. So it makes it so easy. You just go down the sheet and look at each line. Does that meet what I'm looking for? Does that meet it? Does that meet it? And you can go to different compost manufacturers and see what their test results are and how it works for your project. Now, important to note is on the second page, we've asked compost manufacturers to put their suggested directions for using that compost. Because since all compost products are different, there are different best practices for how to use that material. And Michael pointed out that Caltrans and CalRecycle have very certain requirements for what they want the ingredients for that compost to be for those feedstocks. And part of the program is requiring the compost manufacturers disclose those feedstocks to you on the sheet of paper on the backside at the bottom there. So we're here to help you see what it is that you have and disclose that. Now, because compost is such a variable material, if you get one sheet of paper that tells you, hey, this is what it tested at this point in time, that's going to help you. But what's even more helpful is if you have a history of test results and you can look at several different ones and kind of see how that material changes over time at that particular facility. So another thing that the STA program does is require that compost manufacturers test their material frequently. Larger manufacturers have to test monthly, smaller ones just have to test 4 times a year. And this is to ensure that the test results you have in front of you are more likely to be indicative of what you actually get on the truckload. So compost. All right, we said, is all compost the same? Well, it's not all the same, but even beyond that, there's all sorts of organic materials that are in different stages of decomposition. And some people call certain things compost and some people call other things compost. And we at the U.S. Composting Council are trying to standardize what people mean by compost. So we worked with the American Association of Plant Food Control Officials, APCO, to work on what is this definition of compost. Let's define it, let's be specific, and let's make it consistent across the industry. So this is our definition. It basically says that the material has heated up enough to kill off the pathogens and to stabilize the carbon. So we've talked about a disclosure program, and I know some of you are thinking, well, that's great if I have a specification that's really specific. I can look at that sheet of paper and compare and see if it is what I need. But what if I want something more detailed than that? What if I want quality standards? So we have a different program that can help you with those quality standards. One of them is the Consumer Compost Use Program. And this program is one that people in the STA program can enroll in this, manufacturers can enroll in this. Then we give them logos to say that their material is particularly good for these 3 different uses, for trees and shrubs and flowers and vegetables and lawns. And they have to pass very specific requirements for their test results. Here's what they are. It's also on our webpage that you can see what those requirements are. But essentially, we're saying that compost needs to have, at a minimum, these kinds of test results in order for them to be good for these particular vegetative uses. Now, as you've heard from all of these different speakers, it's not just about what the test results are, about what the maturity is, and all these other qualities about the material. It's also about how you apply it. How thickly are you going to put down that material? Will it be 1 inch thick, 1/2 inch thick? Are you going to incorporate it? Is it going to be surface applied? So for these different uses, for these C-cup uses, as we call it, we have put together sheets so that you can look through and see what we recommend those applications be for each one of those materials. So that's only 3 uses. I know some of you are looking at and saying, well, what about berms and blankets and socks? We just heard about how those were great, really successful ways to use compost. What about those? So we do have recommendations for those uses. Again, around the country, for everybody's projects, you might have a different specific something that's happening. Your slope is steeper, or some other quality is happening with your project where you need this specification to be a little bit more detailed for you. So you might want to take our recommended industry specification and tweak it to fit your specific need. But we do have these on our website. These give the parameters for each one of these tested items, what we recommend. And now you've heard a lot from all these other speakers about how this compost worked really well for this particular project, and how much they love compost. We want you to be able to have more of these conversations between Department of Transportation's and between Department of Environmental Qualities and landscape architects to find out what specifications work for them, what they have in use currently, the language around how they put that into specs. So we put that up on our website. Right now, there are a handful of specifications that are up there, and over this past year, I got a grant and was able to gather 70 more specifications. So those will be going up soon. But I highly recommend you look at that. Now, I'm going through all different types of specifications because I want you to have all of these tools in your tool belt and know that they're on our webpage. One of them is this idea about how much organic matter we recommend you have in the soil. So there are all different soil conditions around the country, everything from clay to sand, and you need different amounts of organic matter depending on if it is a xeric plant or if it is a bog plant. They all have different desires, but we worked with a bunch of researchers to find out, well, if we wanted to give people a rule of thumb for this construction site, took off the first few layers of topsoil and we're down the subsoil and we're trying to restore the organic matter so that plants will grow better, how much should we apply as a rule of thumb? We have come up with 5% as the amount of organic matter that should be added to soils, or your soil should have that much. How much you might want to add is different from site to site. So make sure to test your soil before you apply compost to see what the bulk density is and the percent organic matter is in that native soil, and then get those test results from us. that show how much organic matter the material that you want to apply is and what the bulk density of that is. And use those 4 numbers to calculate how much more compost you might need to add in order to get 5% organic matter and increase the water retention for that soil. So I'm sure that you're thinking now, compost is wonderful. We've had all of these great speakers talking about it. And you love this idea of having these test results that are provided free to you by compost manufacturers so that you can compare what type of compost you have available from one place to the next. How do you source it? So we have on our website both a map of facilities in the United States, as well as a list and contact information for those people, so that you can reach out directly to those people to find out all the details of purchasing from them. We're working on making this map searchable because we know that all of you would like a lot more detail in finding the correct product for what you're looking for. So thank you. Make sure to look at our website. And we heard earlier from Michael about people being asked to show that they had the STA certificate, that they had the STA test results. And those are great things to ask compost manufacturers to show you. But what's even more important is making sure that they're still up on our website, because some of the other items that we check compost manufacturers to make sure that they do is to have a permit that is currently in compliance. And if anybody falls out of compliance with their permit, or if they fail a test result, that's going to show up on our website first. So make sure to check the Composting Council website before you choose a compost and before you implement it on your project. So I hope that that is helpful for you, and you choose STA soon.
Okay, Hillary, thank you. Appreciate it. Great presentation on the seal of testing assurance for the end user. Okay, now we'll go over to the questions and answers. So Esmeralda or Ray, do we have any questions that have come in? I haven't seen anything on the chat yet, but do we have anything on email?
Yes, we have a few questions that were asked in the questions pane. The first one is for Zach Tanner, and it is, where does Caltrans procure its compost for its projects, and what minimum standards do you use for your compost? This question is from Jennifer Chong.
Yeah, so the Caltrans projects are contracted out, and so the bidding contractors will have their own sources, and they will, the contract gets awarded to a contractor who then provides the compost. So, I don't know, Mike, if you want to weigh in on that. If I don't know if I can answer specifically off the top of my head any facilities that the contractors have been using lately more than others, but it does vary project by project.
Yeah, and it's pretty much represented on the map that Hillary showed it on the different places that we can purchase the compost. It is a problem, that we have, because California's such a big state. It's very mountainous in areas. And so the transportation costs become an issue. We do have projects that are really out and far hinterlands that are far from compost producers. And so when we start getting more than 50 miles or so, sometimes we really have to evaluate, trucking that compost to the project site and the cost of that. But so that's our biggest challenge. But they're spread out across the state, and like you would expect, the population centers down towards the south have a lot more producers.
Thank you. If that's all that you had to share. A quick reminder that the presentation is being recorded and will be available on the CalRecycle website. The next question is from Drew Reddy, also for Zach Tanner. Are you using native seed on your project sites? Many Caltrans projects on Highway 1 now have pampas grass as a predominant species. How do you ensure you aren't introducing invasive species or high nutrient soils that favor invasive species in your compost blankets?
Yeah, so to answer the first part of that question, definitely. You're using native seeds, primarily using native plants on all our projects. And absolutely correct. I mean, Highway 1, Big Sur, pampas grass is a big issue. So, you know, in all our project sites, invasives are a big issue. And so the approach to invasive, I mean, it's a problem with or without the compost, honestly. These are disturbed sites. You know, highway roadsides are a corridor for weed seed to fly in with all the truck travel and vehicular travel. A lot of our sites are adjacent to ag land as well. So invasives they're just a problem on every site that we have. And really to manage that, you know, it comes down to the invasive plant management practices of the site, really. And then there are instances where, you know, it's hard for us to get vegetation established on a really steep slope, and it's hard to get the water to stay on site. And so in that respect, compost has the ability to, you know, hold some water on site and allow that hydroseed to have a germination medium, whereas before it would just run off site. And so in that way, it kind of does, you know, the compost does aid that effort to allow that native seed to germinate and get established. But the issue with invasives is still the same. I mean, unless we have good invasive plant management, those invasives, they're going to have the same competitive advantage as well. And I think there are others that can probably speak more specifically to how compost may benefit that, but from my experience, it's coming down to invasive plant management is the real difference.
Thank you. The next question is from Veronica Pardo. It's pretty general, so anyone feel free to jump in and answer. They're asking, what can we do as a state to incentivize greater use of compost by entities like Caltrans?
Specifying it, I think.
You want to ask the question again?
Yeah.
Yeah, it says, what can we do as a state to incentivize greater use of compost by entities like Caltrans?
I mean, we're using compost on a lot of our projects. We're specifying it. That gets the demand out there, if I'm understanding the question correctly.
Yeah, I think something important too that a lot of misunderstanding about Caltrans. It really is a lot of those kinds of decisions are made by the local offices, not in headquarters in Sacramento. So Zach represents the office in San Luis Obispo, and he's a designer. And so working with the local office as their projects come up, and those individual designers are educated in conferences like this, and with some of our meetings with headquarters, we've had those for some years now, looking at every case we can to, not use. Mostly what we just really saw the shift at Caltrans, have been there almost 30 years now, is when word came out we should minimize the use of synthetic fertilizers. When that came out, probably about 20 years ago, I'm guessing, where designers are really starting to rethink that, where we were heavy users of that up to that point. Compost really started to come online more and more, and as its availability became such, like I mentioned earlier, where it's closer to some of these project sites, we started to see its use more than ever now. Not just in ornamental planting, which Caltrans still does a lot of it, ornamental planting, especially you get down in the urban areas, but also for like what we're seeing today, so erosion control application. So I think that that message has been with Caltrans loud and clear for quite some time, to use the compost, you know, as good for the environment, good for the plants. I think that's not an issue now with, especially with the newer, younger designers that we now have. That's not an issue. It's just the availability, getting those production sites near some of our construction sites. To me, that seems to be some of the bigger challenges that we're dealing with right now.
And if the state wants to contact me, I think my email is available, then I can partner with you in order to try to get more compost specified. We have resources that you could use. We also have access to researchers that we can get you in contact with to help facilitate the conversation with some of those people that may have questions before they want to start specifying compost. We can also help connect you to different people in state chapters who can help know who some of the players are that need to be spoken to in order to get those specifications written. So I'd be happy to help.
Yeah, and I think Dr. David Rowe mentioned it earlier in the panel one about reaching out to, you know, the landscape maintenance companies and contractors and that, and educating them on the benefits of compost and how they can reach out to their customers and increase their knowledge about it, and how those can be incorporated to make their projects more effective. I think that's another good point as well.
Okay, the next question is, how is Caltrans thinking about compost as a tool for native plant recovery and secession? For instance, on steep slopes on Highway 1, how is annual plant cover being transitioned to deep-rooted native perennials and shrubs?
Yeah, that's a good question. You know, a lot of that is coming through the seed mix that we prepare. You know, we have other requirements we're trying to address as well. You know, we've got, you know, on Highway 1, it's a Smith's blue butterfly habitat as well. So we plant a lot of Eriogon parvifolium for that. That's a perennial plant as well. So, you know, we do want the first flush of kind of annual wildflowers to get in there and get that vegetation established. We also plant a lot of native grasses for this purpose as well. But the seed mix will include other perennials and woody shrubs that will help, that will grow in over time. And the big thing there is, you know, you got a window of time where you got to stay on top of the weed management as well, and assure that the native plants that are germinating are given space and given the opportunity to grow into their full potential. So, and we do container stock planting as well. Kind of comes down to what the mitigation requirements are, the percent of coverage we're trying to achieve. It's a variety of factors, but you know, we do plant, you know, for you know, to get perennial species established as well.
Okay, I think we have time for one more question.
Yes, so quickly, I just wanted to say, Jeff had asked how many cubic yards of compost did Caltrans purchase in 2021? We were told Caltrans uses about 100,000 cubic yards of compost per year in the construction of highways. And then the last question we'll get to is coming from our organics inbox from Jane Mays. It's for Zach. It says, can you elaborate a little on carbon sequestration credits for use of compost in landscaping projects? Is this a widespread project in carbon offset market?
Yeah, unfortunately, I don't know. I don't have that data to really know to answer that question. You know, we have noted it in a lot of the environmental documents where it's applicable, but that's kind of on a project by project basis. So I'm sorry, I don't have enough information to really say, you know, how it's measuring up to the greater, you know, effort to offset carbon, or any data to support that. And I forget, there was a question that was mentioned before. I forget what it was. Oh,
I think there was a
something
question about how many cubic yards we use annually.
yeah.
Jack responded and said that there was 100,000 cubic yards of compost that Caltrans uses in the construction of highways.
Oh, okay. Okay, good.
All righty. Well, thank you. We're at the 5-minute mark, so we will take a break. I want to thank all of our panel members for panel number 2. Thank you for your presentations and the question and answer sessions. And we will be back at 11 o'clock. Until then, here's a little point to ponder. Thank you very much.
Okay, it's 11 o'clock. I'll get started. Okay, panel 3. Good morning, everyone. My name is Scott Blair. I'm a senior landscape architect with Caltrans. I'll be moderating this portion of the webinar today. The theme for this panel is compost use for conservation and water quality. And now I'd like to welcome and introduce our 2 presenters. Dr. Britt Fawcett directs research and technical programs for Filtrex International on organics, recycling, and stormwater management industries. He earned his PhD from the University of Georgia. Britt serves on multiple technical committees with ASTM and is a board trustee for the Compost Research and Education Foundation. He has authored 3 books and numerous peer-reviewed publications on organics and stormwater management. And Dr. Sally Brown is a research professor at the University of Washington. Her work focuses on the benefits of compost and other organic residuals. She's also a regular columnist for the BioCycle Connect. Okay, Britt, when you're ready, please take the floor.
You bet. Thank you, Scott. And thanks to all of you for tuning into the workshop today. I know your time is precious, and really particularly this time of year. If you'll permit me, I'm going to temporarily turn off my camera as I move through the slides just for bandwidth issues, and I'll promptly turn it back on for the Q&A, I promise. There we go. A little test. Oops. Let's see. I'm going to begin by making the assumption that not everybody on the webinar has a background in stormwater management. And that's okay, because it's really a great place to start to not only talk about stormwater, but how compost fits into the equation and really why we care and really what it can do in stormwater applications. And then selfishly, honestly, this is one of my favorite slides of all time. So it really does a really nice job graphically of, of showing what happens as we change our land use patterns from natural systems like you see on the left-hand side, lots of natural materials, biomass, tree canopy, grasses, rootstock, organic matter on the surface of the soil, in the soil, all these things working together to keep a tight and efficient water or hydrologic cycle. And you can kind of see what happens as we get rid of some of those natural systems, natural materials, as we move to the right with greater land development and land disturbance and suburban and urbanization. What happens is you see that red kind of creeping in, and really what's happening is we're breaking the water cycle, and we're having a pretty profound impact on watershed hydrology. And you see here in the color coordination that there's greater and greater stormwater runoff. And there's tons of studies now that show that the more stormwater runoff we have, concomitantly, the higher the pollutant load in that stormwater. And all of that is getting into our surface water bodies. And I've typed that into the slide here. We really don't have to look any further than to look back at nature to see what she does in order to manage and mitigate and minimize this stormwater. And in reality, we kind of have 2 key solutions at hand. We can seek to reduce the color red there by reducing the stormwater volume. And actually, compost has a pretty big impact to play in that area by absorbing rainfall as well as stormwater and minimizing the volume. It also has a pretty big role to play in terms of treating that pollutant load as well that we find in the stormwater, really through stormwater treatment or biofiltration mechanisms. And that's really the focus of my talk with you today. Now, I realize that very few folks actually work on a watershed scale. Most folks who work in stormwater are going to work in some form or capacity at the site scale, and that's one of the reasons why I'm sharing this slide with you. If you look at the percentages here, you're going to notice that the percentages are very much the same or very similar, hydrologically speaking, to what they are at the watershed scale. But there's another reason why I'm sharing this slide with you. And if you look at that arrow that's pointing down, surface water detained and infiltrated, we know in natural systems what happens when rainwater or storm water moves down through that soil profile. It gets naturally filtered in the process, whether it goes down deep and recharges our groundwater systems, or perhaps it moves shallowly just below the soil surface, what we would call subsurface or interflow. It actually also gets naturally filtered before it may reach one of our surface water bodies. It's really a form of biofiltration. And it's that idea and that concept which actually we're harnessing and we're putting and we're utilizing with the compost filter sock, and now we don't have to have that infiltration. We're actually taking it and we're putting it in the flow path where we know we're going to have runoff, or we know we're going to have polluted runoff, and we can actually deploy it, install it, design it just about anywhere we need to on a site, and really in the most critical areas. And the concept behind this is actually pretty simple. It's biomimicry or innovation inspired by nature. If you're somewhat or relatively new to this, you may be a little surprised. There's actually a lot of research that's gone on in evaluating the performance and the development of these applications of compost-based BMPs and even compost filter socks specifically, published in quite a few different journals. You may also be somewhat surprised to learn, and some of the other speakers have talked about this, but basically every federal agency or national organization that has the ability to create a guidance document or a specification for compost filter socks basically has. The US EPA's National Menu of BMPs, the USDA NRCS, the Army Corps of Engineers. The very first one was the American Association of State Highway Transportation Officials, the US Composting Council. Hillary talked about that earlier. And then at least one jurisdictional agency in all 50 states has also done so. And by that, I mean either the Transportation Department or the State Environmental Protection Agency. And of course, in California, that has also occurred. I want to give you a snapshot of what some of these look like in the field, because they're really used in a lot of different applications in a lot of different ways, whether it's a perimeter control of sediment, like you see in the lower left-hand corner, inlet protection, which you see in the middle, a check dam application you see in the middle right. You can actually stack them in a pyramid configuration into a sediment trap to handle much larger drainage areas. Slope interruption devices you see on the left hand in the middle. Pre-treatment systems around bioretention and rain garden systems in the upper left-hand corner. You see it filtering pollutants coming off of roadways and streetscapes in the lower middle. Most recently, we've seen it used quite a bit in post-fire stormwater treatment and sediment control applications you see in the upper middle photograph as well. So when I talk about these applications, generally there's one of two types of compost for the most part that we're utilizing. It's either a filtration media, or we often call it a biofiltration media. Mike referred to it earlier as a coarse compost. As specified through Caltrans. It's a very coarse media. You'll notice that on the right-hand side, it's another type of coarse media, but not as coarse. It's typically used for compost blankets for erosion control. But we're going to be focused on this filtration media, this coarse media. And it's really designed for optimum filtration of pollutants, not just sediment, but also stormwater pollutants, as well as the passive flow, hydraulic flow of water, because we don't want to dam up water. We want this material to act as a passive biofilter. Now, if you're thinking to yourself, you're looking at this image and you're thinking, wow, that doesn't look like compost to me, or it doesn't look like any type of compost that I'm used to buying at my local garden center and using in my garden or in a soil blend. Ding, 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 you're absolutely correct. And that's actually a key take-home message. I would actually go so far as to say that if you're utilizing that type of compost in this application, it's a low quality compost simply because of the particle size and no other reason. So it's really, really important that you utilize the correct compost in these applications. And for this, the particle size is pretty critical. This slide does a pretty good representation of describing why that is. So it really shows that particle size matters in these applications. So if you look at the particle size at the bottom, this is in inches, going from left to right, 1/4 inch to 2 inches in size. As you select for those larger particles, you see what happens is that flow through rate goes up, that water flow through rate goes up. filtration ability begins to gradually go down. And as you select for those smaller particles, as you move to the left, really below 1/4 inch, and this is getting really similar to that bagged product that I referred to earlier, you see that flow through rate goes down to basically nothing. Filtration ability continually goes up, and really at the top there, it's just blocking everything. It's not even filtration anymore. We're just blocking water, and we're blocking pollutants, and that's not what we're going for here. And you can see that this is what happens when you choose the wrong a compost media that is too small. It just blocks everything, and we're not going for a barrier. We're going for a filtration device. Consequently, for those of you who know straw wattles, actually this is what a straw wattle does. It mimics what you see at the left-hand side of the scale. It's just a barrier. If you're familiar with silt fence, it actually does the same thing. And we're not trying to we're not trying to do that. We're trying to have a system that both filters and allows water to move through. So it's a true biofilter. However, it does restrict flow to a degree. Anytime you put something in a flow path, it will. So it really combines both filtration as well as sediment deposition when it's used correctly. And really the concept behind this is actually nothing unique. It's the same concept used to make water filters that you probably have in your home right now, in your sink or your refrigerator, or even an air filter in your HVAC system at home, or an air filter in your automobile. You increase those apertures, more flow goes through, more pollution goes through. You cinch down on those apertures or pore spaces, and then you slow down the flow rate and you trap more stuff. It's the exact same idea and concept. Excuse me. One of the things that's actually really unique about utilizing compost as a biofiltration media and then a compost filter sock is there's really a three-way biofiltration component to it. The first one is physical, and actually this one is not that unique, and I've already been talking about it. By manipulating the particle sizes, we create a variety of pore spaces, allowing water to move through, and we trap particulates and sediments in the process. We also slow down water flow, and that allows sediment and particulates to settle out as well. But here's where it gets interesting. There's a chemical component as well, and I don't mean we're adding chemicals, but I mean that compost media has the ability to filter, really sorb or adsorb some soluble forms of pollutants that we typically find in our stormwater. Ammonium nitrogen and some metals are good examples of these. You may not know, but that per particle, a compost has an extremely high surface area and has the ability to trap and sorb some of these pollutants. The idea is actually very much the same, or the concept is very much the same as activated carbon that you may have in a drinking filter at home. It's just that the surface area is not quite as great as it is for activated carbon, but the idea is the same. There's a biological component as well, and we know that a mature, high-quality compost has both a high population density as well as diversity of beneficial bacteria that can actually degrade and transform a lot of the pollutants that we're talking about here, really in situ or in the field. It's really the same concept used in bioretention system, rain gardens, and constructed wetland systems. There's actually a fourth component here that I haven't typed in because it's more of an option, and that is including plant materials, certain plant materials you can select to then uptake some of the pollutants that we're trapping, thereby taking the pollutants out of the flow path and increasing the longevity of the compost filter or the compost filter sock as well. So I want to share with you a little bit of research that shows some of the performance of the compost filter sock as a biofilter. So this is done at the USDA Ag Research Service outside of Washington, D.C., comparing a compost filter sock to silt fence for total suspended solids, removal efficiency, and reduction of turbidity. You can see the percentage reduction values there, as published in the Journal of Soil and Water Conservation. A similar study done right here in California at San Diego State University, utilizing an ASTM standard test method typically used for erosion control materials, looking at the total sediment removal rates or removal efficiencies for compost filter sock compared to straw wattles, 77% to 59%. And then also a follow-up study that the ARS did to really begin to look at the compost biofilter and compost sock as really a true biofilter, not just looking at sediment, suspended solids, and turbidity, which they did in this compilation of studies, which you see here in the first couple of columns, but also looking at soluble forms of pollutants, because in the post-construction stormwater context, there's a lot of studies on this now. the inverse of what we find in construction activity is true. So in construction activity, we target sediment because that is by far the biggest form of pollution is sediment. And conventional wisdom says if you trap the sediment, you get the other forms of pollutants as well because they'll often attach themselves to those sediments. In the post-construction context, that is not true, or not so true. In fact, the total pollutant load can be 80% in the soluble form. So these systems, these technologies, these practices need to be able to target not just sediment, but also soluble forms of pollutants. And that's really the point of this compilation of studies that the ARS performed. And it's been published jointly in the Journal of Environmental Quality and Journal of Stormwater Conservation. But you can see removal rates here for total nitrogen, ammonium nitrogen, phosphorus, total coliform, and E. coli bacteria. They looked at a variety of metals: copper, cadmium, chromium, nickel, lead, and zinc, motor oil, and diesel fuel. And then finally, one of the things that I'm most excited about in recent developments related to these compost filter socks is the introduction of natural fiber and biodegradable meshes to go along with the compost filter sock. This hasn't always been the case for some years with these compost biofilters. They've often used plastic meshes and nets, and now there are natural biodegradable options to make it a truly 100% natural biodegradable system that can be left at the site, not removed, which really honors the promise of one of the reasons why we want to use compost in these applications, thereby not taking anything to the landfill and recycling materials. But there's lots of different reasons why folks have become interested or are interested in utilizing a BMP like this, whether it's obviously minimization and reduction of petroleum-based products, trying to prevent microplastics from forming not just in our landscapes, but migrating to water bodies and of course the oceans, preventing materials going to landfills, reducing labor or actually eliminating the labor cost to remove anything at the end of a project. Preventing wildlife entrapment, landscape equipment entanglement are pretty big deals in some applications and areas. And then obviously just having materials and products that are compatible with the permanent and the natural landscape. And with that, I think I've used all my time, and I'm going to turn it back over to you, Scott.
Awesome, Britt. Thank you for the informative presentation. And now we'll move on to Dr. Sally Brown. Sally, please start when you're ready. Thanks. Sally, you're muted.
Thank you. Okay. Sorry about that. This is more of a story rather than a how-to, but it's a way to think about things that you haven't necessarily thought of as possibilities, and how to make them into realities, and they involve compost and highways. So there's a program that's a local program, nationally recognized program called the Mountains to Sound Greenway. And it's what I'm going to tell you about today. And it's just a way to rethink what a highway or a road can be. So here's a map of the Seattle area. You can see the Space Needle in Seattle, and you can see a bunch of mountains and green stuff. And this whole program is to keep that path from the mountains, and in fact the program extends beyond the edge of this map to the sound as a green way. And next slide, please. When you think about highways and nature, you usually think of them about the same way as you think of what AOC and MTG have in common. If you don't mind that political comment there. You somehow don't picture either of these two representatives in our house as sitting down and having cordial lunches together. The same way you don't see the picture of I-5 in downtown Seattle and this beautiful shot of Mount St. Helens here having anything to do with each other. But we would all be better off if one could recognize common ground and how shared goals could bring these two closer together. We're going to focus on the highways here and the natural component. I think that might be an easier, less of a stretch than the political end, but let's go for the next slide. Okay. The Mountains to Sound Greenway program was the brainchild of a guy named Jim Ellis. And I had the pleasure of knowing Jim Ellis. He died a few years back at, I think, 98. And he helped make Seattle, he helped beautify Seattle, clean the waters of Seattle. He was just a wonderful man. And I refer to him here as the Betty White of Seattle. And I think everybody will get what I mean. He grew up in this area in the Northwest. And one of his favorite stories to tell was how his parents dropped him and his brother off in the middle of the woods in the beginning of the summer and came back 2 months later to pick them up. And they had to figure out for themselves how to build shelter, how to find food. And this was one of the formative experiences in his life. His brother was later killed during World War II. And his wife at the time, when Jim was so depressed at the loss of his brother, said, you got to make something to remember your brother. And the Mountains to Sound Greenway was how he remembered his brother. Jim became an attorney, and he was one of the founding partners in a firm called Preston, Gates, and Ellis. He's the Ellis Gates. You may know that name from other industries based in the Seattle area. And it was his love of the woods, his love of his brother, that gave him this inspiration to come up with a way to preserve the green space around this major, major highway. And next. In one of his stories that he would tell, he would talk about how he got the idea for this Greenway project and knew he would need some big name sponsors. And so he made a few phone calls. He made these phone calls at lunchtime to the CEOs of these companies, Weyerhaeuser, Boeing, and Microsoft, because he knew that at lunch, the secretaries wouldn't be there and that the bosses would answer their own phone calls. And sure enough, it worked to get him through the head of Weyerhaeuser, the head of Boeing, not so much the head of Microsoft, but that came a few weeks later. He got their support for this crazy idea, and that's how the Mountains to Sound Greenway was formed. So next. And here you can see both the logo for the Mountains to Sound Greenway and an aerial view. It's the aerial after a big climb up, but that little strip of roadway is I-90. And I drove it yesterday, and it is spectacular. And a lot of the reason that it's still as green as it is because of this nonprofit Mountains to Sound Greenway. If we go to the next. Here is a slide from Mountains to Sound. It should have their web address on the bottom there. And you can read here, basic mission of the Mountains to Sound Greenway is that people's lives are better if there are trees in them, or pastures in them, or green space in them. And this has been shown. Mountains to Sound was founded in the early 1990s. And you can see in the literature that more and more you see the whole concept of nature bathing or exposure to nature as truly linked to better health, happiness, peace, calm. It's all true. Go take a walk in the woods and you'll feel better. And this is the goal of the Mountains to Sound Greenway. Next. one of the things that was pretty forward-thinking of Mr. Ellis when he was creating this nonprofit was to realize how materials from the city could be integrated into this whole Mountains to Sound Greenway concept to preserve the green space and to strengthen the health of the green space. The whole Seattle area, Weyerhaeuser, based in Seattle, was a logging company, and we used to have very big trees, and commercial forestry is still a very important industry in the area. There's privately held lands, there's publicly held lands, and logging from these lands helps on the public end to pay for education and schools in the state. Way back in the day, when trees were this big and mountains were logged, there were big scars left from logging, and it wasn't necessarily done in a sustainable fashion. But Jim recognized that the viability of commercial tree plantations was a great way to keep the area green. When you're driving past these forests, you don't necessarily first think, this is a commercial tree plantation. What you see is this is a green forest. Next. And so one of the big ways that compost use was integrated into the Mountains to Sound Greenway was to take out old logging roads. Compost made from urban residuals, primarily biosolids and yard waste at this point, was used by a crew of volunteers every summer to take scars from logging. This is part of the Zorro road cut, which was a very visible, very unpleasant, and now long gone road cut that you would see when you drove on I-90. They would pull back the road with range of equipment, put heavy rates of compost down, and seed it in sterile grass, and then it would get gradually taken over and restored to forestry. And this is one of the ways that this was part of the initial agreements for the Greenway, that compost use would be an integral part of the process of keeping that green. And next. Another thing that was very innovative at the time was that an agreement was made with King County, which is where Seattle is. It's the most populated county in the state, and I-90 cuts right through it. The municipal biosolids from wastewater treatment would have a place in the Mountains to Sound Greenway. Biosolids for tree fertilization was end use for biosolids that was initially researched at University of Washington, where I work, and King County. My husband, who is out in the garage right now, was one of the people that started this program. And you can see in this tree cut exactly why it works. You can see the narrow rings, and then all of a sudden you can see the biosolids application, and all of a sudden the tree rings get wider. So when you fertilize tree plantations with biosolids, you get bigger trees, you get more money from a logging industry, and from a municipality like King County, you have a close end use site for your biosolids. So it's a win all around. This has been seen, increased tree growth, multiple studies here, Canada, New Zealand, CA is Canada, not California, but confirmed different tree species, different types of forestry. This works. And next. The way it works, and here is a slide of the King County Biosolids application vehicle. The biosolids are applied with a self-loading side-cast spreader. The side-cast spreader has a throw distance of about 200 feet. And it's self-loading, and it is an adapted machine from the logging industry. Typically, the trees are planted, and when they're 4 to 6 years old, they get a first application, get subsequent applications until canopy closure at about 18 years of age. Then, as happens with people, mid-30s, they get thinned. Some of you men out there have had thinning problems in your mid-30s as well. And the applications can resume after commercial thinning again until harvest. Next. This is part of what I do. This is part of how I get paid as a professor, is I go into the woods, and this is funded through King County as part of the Mountains to Sound Greenway agreement. It's a long-term research contract with University of Washington. And I go out and I look at the trees, I look at the understory, I look at soil pits, I look at soil data. If I see a lot of nitrogen fixing species like alder or Scots broom, I have a clear indication that this is a low nitrogen soil, could use the biosolids. Type of ferns indicate quality of the site. It's a really nice way in the fall to go look for some chanterelles, in the spring to go look for some berries. It's a wonderful opportunity, not yet, but it's okay. We're not quite ready for this slide, but it's a wonderful opportunity to see deer, elk, and bear. And in fact, this is a paper we just published. It, in addition to making the trees grow bigger, it also makes the soil store more carbon. We did a carbon accounting in conjunction with wide, expansive soil sampling, and found that in the lower carbon soil where we sampled, we were seeing soil storage equivalent to about 5 tons of CO2 for each ton of biosolids applied. So here you are, you're keeping this Mountains to Sound Greenway green, you're getting bigger trees, and you're also storing carbon. So it's a great deal all around. And next. You can read about this. I did a column for Biocycle on Jim Ellis that's earlier in the presentation. You can get the link to that. And here you can read all about the benefits of fertilization. And here biosolids are used. Compost works fabulously for trees as well. And you get beautiful, beautiful forests as a result. Great for restoring gravel pits, great for making things beautiful, even around highways. And next. How this goes to water quality, if you go and remember the first slide that Britt had shown, if you get things closer to natural systems by rebuilding and restoring natural systems, you improve water infiltration, you improve water retention. And this is a slide from the Greenway. You keep the streams clean and the water levels high, which is important for the people that want to raft on the river. It's also really important for the salmon, and salmon are really critical here. The Mountains to Sound Greenway has a wide range of hikers and other recreational activities associated with it. And here you get the human benefits, the health benefits, the economic benefits. You also get less angry drivers. It's much harder to be furious when you're stuck in traffic if this is your view from the highway than if you're looking at a Target parking lot or a Costco parking lot. Trust me, I've been there. I drive this road all the time. And next. So Mountains to Sound is a unique program. And it's in a special area where we can have these enormous trees. But in California, you got your own beauty and you got plenty of it. So as you're thinking about compost and compost as an amendment for your right-of-way on your highways, think bigger than that and think of compost as a tool to make your highway a bridge to nature. And think of what beautiful world you can create with that. And you got a nice road right to it. And that's all I have. Thank you.
All right, thank you for the presentation, Sally. And then next up, Ray and Esmeralda, can you please start the Q&A session? Thanks.
Yes, thank you. So one of our first questions is coming from Kristen Nix, and it is, what are you seeing in trends in natural and biodegradable netting materials for socks and blankets instead of plastics?
Can we take that one? Sure, I'll take that. Seeing a significant trend in that direction, not just certainly in California, but really all over the country. And it's happening at a different pace, depending on what state you may be in. But there's certainly states now that have transitioned all the way to only allowing or requiring natural biodegradable materials. There are quite a few that are in the process of that transition and have stated dates when they hope to achieve that full transition. And of course, you have others that are still working on a plan to begin that transition. But it is definitely a hot topic, and we're definitely seeing a lot of interest all over the country. Good question.
Thank you. Next, we have a question from Mark Caro. What is the general cost difference between using compost and compost socks versus BFM and straw wattles?
That's a good question, and it really, in many cases, it depends on the project. It depends on the location and where you are. What we've seen, there's a couple of things I will say. We'll talk about straw wattles and socks first. If you're only looking at if you're looking at the same size and you're only looking at the upfront cost, straw wattles can oftentimes be a little bit cheaper. However, if you're looking at the total life cycle cost, not just the product cost, but the installation, which is a lot easier and faster with the compost filter socks. They don't require trenching. The maintenance, removal and disposal, all that actually, that life cycle cost makes the total price or the total cost of ownership of that BMP cheaper than a straw wattle. Also, they just perform better. And so if your goal is performance and protection of water quality, which generally it should be, you're going to have less replacement and just more assurance that that it's going to be protecting water quality. Compost blankets and BFMs, it really depends on the application, the BFM product you're talking about, and the application depth. In some cases, those BFMs can be pretty expensive. And with compost blankets, you have the option of depths depending on the steepness of the slope and how long the slope is as well. Anywhere from really 3/4 of an inch is really the minimum, and 2 inches is a maximum. And so that price can range quite a bit for that material as well. So they're, and long story short, they're both all of those are really competitive, but it's really the life cycle cost for the most part that's really going to be cheaper for you for the compost BMPs.
Thank you. The next question is from Matt Jones. They ask, is compost a good option for ground cover weed abatement on a sandy base? What is the process for use in this manner?
You want that, Sally? You want me to take that?
Compost for weed abatement. It depends on your kind of weed. If you have nitrogen fixing weeds and you use a high nitrogen material as a ground cover, it'll encourage competitors that are not dependent on the nitrogen. Compost, you have to make sure you have STA certified material, because that'll make sure that you have weed seeds that are dead, as opposed to bringing in more weeds with your material that you're using. And not necessarily. Compost and weeds, weeds are plants. Plants love compost.
I would add a couple points. I agree with everything Sally said. You compost in a surface application can have a mulching effect that can dampen out the establishment of some weeds. And it feels like eons ago at this point, but I did a study when I was at the University of Georgia that looked at a variety of hydromulches and compost blankets. And Sally's absolutely correct. The higher the nitrogen content in whatever that material is, weeds really respond to that. So when you are selecting whatever media it's going to be, lower nitrogen, if you're trying to minimize weeds and really attract natives and grow the natives well, minimization of that nitrogen is pretty key.
Yeah, one thing to add with that, if you do put down, there's actually 2 parts to this. If you incorporate the compost, it's going to generally make for a better soil in the future than a surface application alone. And the other thing to realize is if you put down the compost and you plant a sterile crop like a sterile wheat or sterile rye, that will be a really good way to take advantage of the growing ability of the compost and to choke out the weeds that try to germinate.
Thank you both. The next question is regarding industrial facilities with COD exceedances. Would you anticipate the use of wattles with compost filter media potentially adding to further escalated COD results?
Generally, no. That's a good question. Oftentimes what we see with COD and BOD is if you can do a good job of not just organics, but really nutrients in general, you can really knock those numbers down. And what we've seen, as long as you, and this is where the specification and selection of the compost is key, you select a mature, high quality compost. You're also selecting, in a lot of these applications, will also self-select for low nutrient types of compost. So those that are coming from woody materials, yard debris type compost also helps. And then actually selecting out those smaller particle size. I talked a lot about particle size and that coarse media. You're also selecting out those small particles, obviously, when you do that, and it's those small particles that have some of that elevated nutrient content. So by doing that, you're actually able to create more of that filter than something that could potentially contribute. And that's really the key.
From a stormwater and green stormwater infrastructure perspective, the other thing you have to realize is by using these compost socks, especially when they're made of biodegradable material, you're going to get plant growth, or you can get plant growth. And that will also do a big job of eliminating COD and BOD.
Thank you. The next question from Drew Reddy is for Britt. Are the larger particle size composts you showed used only in socks, or are they also being specified for subsurface application in bioretention soil mixes?
That's a good question. And it kind of depends on the specification and where you are. I've seen the gamut in particle sizes for subsurface bioretention systems from, and it's not my recommendation, but using the finer composts to all the way to what I showed you with the coarse composts. I think it depends on the pollutants that you're trying to target in that general site and watershed, but really it's a combination. If you're looking for biofiltration, specifically that coarser grade material, but you got to complement that with a little bit of smaller material to allow for vegetation to establish, particularly at the surface, less so down through the profile of the media. Sally has some experience with this too. She'll probably want to share.
It's, yep. Just nodding. Okay.
We had a second question from Drew regarding, I'm sorry, I think it's also about stormwater. So for Britt and Sally, please feel free to chime in as always. It would seem especially important that composts used in stormwater management have minimal plastics and pathogens. How will we test, grade, enforce compost quality in stormwater management moving forward to ensure we aren't adding pollutants to our roadways, neighborhoods, and right-of-ways?
It's an excellent question, and honestly, some of the previous speakers did a really nice job, I think, of talking about some of this in terms of following the specifications that call out plastics and the maximum allowable plastic content that we are allowed to have in these composts for these applications. There's also part of the testing is for fecal coliform as well, so for the harmful bacteria. And it's really critical that you do those tests and you meet those specifications. If the compost that you're seeking or you're utilizing does not have that type of testing and does not meet those specifications, you don't know what you're going to get, and there could be an issue. So it's really important. This testing and meeting these specifications is so critical to these applications, really not just in stormwater, but a lot of the applications that folks have talked about.
Okay, the next question from Scott Batari, also a little bit about stormwater and particle size. They ask, are you saying that mostly 3/4 inch particle size compost is optimum for both flow and filtration in stormwater treatment?
Yes, pretty close. So the general specification is about 50%, 50 to 60% above 3/8 of an inch, and the rest can be below. That's for the compost filter sock. That's generally the specification. Varies a little bit from state to state, but that's the general specification.
Thank you. The next question is from Ruby Baracuatro. How will or has Caltrans worked with indigenous communities in restoration and or compost application programs?
I don't know that I can answer that one. If there's somebody from Caltrans that's still on, they'd probably be a better person for that. It's a good question, though. Jack.
Did you want to repeat the question?
Yes, they asked, how will or how has Caltrans worked with indigenous communities in restoration and or compost application programs?
All right. And yeah, that's a hard question to answer from this perspective. Each individual of our 12 Caltrans districts has a design branch or unit for the specific project. So when we get into specific areas, we work with the local people, whether it's a tribe or indigenous people or the city or county. We work with them. On larger scale projects, we develop either maintenance agreements or freeway agreements as we move through. But there is a lot of that engagement with the locals. Hope that covers the question.
Thank you. The next question we have is from Drew Reddy. This is for Sally. They're asking, many of California's chaparral and sage shrublands, which make up a good part of our wildlands in California, are not known to prefer high nitrogen soils. How do we identify where compost has a net benefit and where it can be detrimental?
Most of your composts or your yard waste composts are going to be relatively low nitrogen, and that won't be a concern to have excess nitrogen adding to these systems. You can assume that most of the areas around a roadway, the soils have been heavily engineered and disturbed and will benefit from compost use. Depending on the state of the soil or the state of the landscape, and Britt showed this data. I've done different work with this, not in relation to Mountainstown Greenway, but basically what Britt showed is correct. You get better water retention, you'll get better water infiltration, so you'll get a healthier, more stable landscape. And generally the areas, certainly in immediate proximity to the roadway, almost guaranteed or disturbed, will benefit from the compost addition. And see, Britt even nodded.
Have nothing else to add.
Thank you both for that. The next question is the netting used to contain compost socks durable enough to not fail next to creeks or fish passage restoration work? Generally, direct compost materials should be kept out of creek flows, or some compost in creek waters is not damaging.
Yeah, that's a good question. Generally, yes, but I'll say, nothing is 100% durable to any situation that you can think of. So, but the materials that we use in those applications are extremely durable. They're meant to last a long time for those applications that are intended for that, and it takes quite a bit to rupture them and to break them. Yeah. Now, if you you know, you try to run over it with a dump truck 20 times and, you know, you're dragging it around the highway a couple miles, it's not going to hold up well for that. But generally speaking, yes.
I'll also add that compost and waterways are not necessarily a bad match. Depending on the compost, we've used compost to restore wetlands, and there can be a great source of organic matter in water bodies that does not end up resulting in eutrophication. It can be a real tool. So the other thing to realize too is some of these socks and blankets can give you plant growth, which will stabilize the material and leave it so it can be a permanent fixture in the landscape and not something that has to be removed. And as it gets covered in plants and becomes a growth medium, in addition to being a filter medium, it will do its job better.
Okay, and then this is the last question that we're seeing right now from Scott Batari. What minimum and maximum thickness do you recommend for roadside erosion control blanketed areas? And do you recommend that EC blankets not be capped off with other EC materials like hydromulch or binders?
My recommendation is a maximum is 2 inches. I've done some research in this area, and you get above 2 inches as far as the erosion control blanket goes, and it can be more difficult for the seed to establish itself. And you really don't get really added performance at that point. Minimum is generally, if you're talking about an erosion control blanket application, 3/4 inch to 1 inch. And the reason for that is what you're really trying to do is it is sufficiently 100% cover the bare soil. And it generally takes about that much in order to do that, so you don't have bare spots. And that's really the key, because part of the benefit of a compost blanket, and really any blanket for that matter, is to prevent splash erosion from occurring when raindrops hit the soil, loosen up those soil particles. So you do that sufficiently, and you're preventing that first stage from occurring. I think did I answer all the question? And if there's a second part to that.
No, I believe that was all of it. We also have a comment that came up in the question pane. If either of you would like to address or speak to it. Ron Alexander notes, for natives, use lower nitrogen compost yard trimmings with 95% organic nitrogen, which slowly releases.
Yes, Ron.
Yeah, most of your compost is going to have relatively low ammonia and nitrate as well. You want a higher C to N ratio is another way to judge, or another tool.
Is that all the questions?
That's all that we have for this panel.
Okay. Thank you for the questions, and thank you, Dr. Fawcett and Dr. Brown, for sharing your time and expertise with us today. And Heather, at this point, I'll turn it over to you to close out the day. Thank you.
Hello, everyone. Thank you so much for joining us, and thank you so much for all of the great presentations from all the wonderful presenters. I think that was a wealth of knowledge. We really look forward to seeing you back here at 9 a.m. tomorrow to hear presentations on compost use for agriculture, city projects, and urban landscaping. We've got a lot more great information in store for you. I know we had several questions from earlier panels, and we will do our best to get back to you by email on those as soon as possible. Jack, any other closing thoughts for today?
I want to thank all of our presenters today. You guys did a fantastic job. Apologize about the little glitch this morning. Rest of the afternoon or rest of the day seemed to work pretty well. And you guys, will see you back here tomorrow, 9 o'clock. Thank you.
Thank you.